I'm audible. Hi. Hello, everyone. Good evening. Hello. Hi. Good evening. I'm audible. Okay. Hello. I'm audible. Please reply. Yes. Good evening, everyone. Okay. So before starting the session, I just want to share one announcement. I just want to share one information. Okay, that we have made some changes regarding the certification. Okay, many of you are asking, sir, whether we are getting the certificate or not. In last few days, we have taken the test, and we found that many of you are just only giving the test. Okay, same numbers are not taking the classes. Okay, so I know that the generation is actually working about the certificates, and they are not worrying about the knowledge. So that is why we have modified our some terms and conditions. Okay, or you can say the rules. The rules is now that I have shared you the tools. I am giving you the knowledge, right? So what I'm going to do it now here, that I will provide you the certificate only after completing of the project. Okay, again, let me clear one more time. We found that many of you are just appearing for the test. Okay, everyone is asking, sir, I have given the test, I'm not able to get my certificate, or etc. etc. So we have received a huge number of queries. Okay, so just to avoid these things, I know that this maybe you have a thought that I am not willing to give the certificate, or maybe I skip your message. Anything can be happen. Anything can be happen. So I don't want to create any misunderstanding. Now the changes which I have made it here, that we are going to provide the certificate only to those candidates who will submit their project. And project like whatever I'm going to help you to design, okay, to understand. For that you require the tool, you require the knowledge, you require the working. I am providing you everything, right? So what you have to do it here, you have to design the project as per your understanding, and then you have to let us know that I have completed my project, sir, please evaluate it. Then I will let you know how to share your design files. Once you share me the design file, once everything is okay, then I will help you to get the certificate. This is one thing. Okay. Second, that I will also take one test, and that test is only one time I will take the test. I will not allow you to take the multiple tests. The first test and the last test, in that only, that I will cover the objective type of questions which I have asked you, or which I have taken in the YouTube classes. Okay, for example, that combination. Right now we are doing the combination. So after the completing of the combination, we will give you the one test, simple one test. And in the one test, that test is not open for everyone. Okay, that test is only for those who have really done the project, or who are really serious to take up the project. Okay, so the people who all have submitted the who all have submitted the project, Okay, if it is working or if it is not working, they are also eligible for the written test, okay, or for the certification test, right? So each and every information we will share you on email. You don't have to worry. And sorry that there was a 2 week gap, because in 1 week I was busy in taking the workshop on Python on FPGAs. This is a new technology which many of you don't know, because you never have a thought that Python can also be used to control the hardware. So this is not a new invention. This is already a 7 to 8 years old invention. If you guys are working on the digital, if you guys are working on a very long VHDL, you should also control the hardware of each and every components on the board available, like each and every components available on board with the help of Python. So that we call a PINC, that is a Python on Zynq, right? So we will give you the more exploration on this later on. And second and the last week I was busy in some personal commitment. Okay, so today I'm going to cover the two topic which was pending. I'm not sure whether you are aware of it or not, but in my third and fourth class, I ask you that to make the full adder with the help of NAND gate, and then let's optimize it. Okay, and then I also gave you the other task that you have a you have a two you have a you have a two half adder, and with the help of two half adder, make a full adder. Okay, so this is the two question basically people ask in an interview. So I'm going to share my thought, uh, my experience. Okay, it will take time, right? It will take time. By that time, please be there. Please hold your whatever you are doing. Please focus on here so that you understand, right? So let me focus. Let me focus on those two topics. So let first take the full adder implementation using half adder. Okay, this is our last theoretical topic with respect to the adder, full adder implementation using half adder. Okay, I will take time to complete these two topics, so please have a patience. Full adder. As I previously mentioned that adder, we required adder to make our project, like calculator. It's also required in algebraic equation, and it also required in geometry equations. Okay, when I'm saying algebraic and geometric, that means a plus b square equal to a square plus b square plus 2ab. So here plus means adder, plus means adder. Okay, ab means multiplication. Okay, so we are going to implement the equation with the respect to the hardware. So for that we are actually working, right? So full adder. So what is full adder? Full adder is basically a two input device. Again, full adder is basically a two input device which is used to add the two input of single bit to multiple bit. And we are getting the output in terms of sum and carry out. Okay, full adder also has a one virtual input C in. Okay, carry in. Okay, this carry in is not any physical input. Please remember this. Many of you are explaining that full adder is a three input, half adder is a two input. No, both are two input device, right? Carry in is a virtual pin which is generated or which is adjusted in a previous output. Okay, so any output which is coming from the previous adder, which is going to adjust through Cin, right? So let me start here. So full adder. So first, so we will write a truth table. Okay, whenever you are facing any interview, please start with the truth table. If you don't start with the truth table, you will not get the time to thought. So whenever you are giving any interview, please focus on writing the truth table. Okay, so 0 0 1 1 1 0 and 1 1 1. Okay, so here our question is to implement a full adder with the help of half adder. Okay, this is my one half adder. This is my another half adder. Okay. Now we have to use these two. Okay, we have to use these two, and we have to design a full adder. Okay, again, this is a little bit logical. If you have done the practice, okay, then only I will allow you to do it. Okay, so again, you have only two half adder. This is your A B. This is your A B. This is a one half adder. This is another half adder. Okay, let's name it A B sum and C out. Okay, this is your sum and this is C out. Okay, suppose that you are giving the interview, right? I am your interviewer. I have asked the candidates, okay, hi, hello, how are you? I'm doing good, sir. Okay, so how's your stay or how's your journey? Everything is fine, sir. Thank you very much. Do you like water? Yes, sir. Thank you very much. Do you like tea or coffee? Yes, sir. If it is okay, please provide me a tea or coffee based on your interest, right? So in this way, you can communicate. Don't say no. Say yes. Okay. If interviewer offer lunch, please say thank you. Definitely go for anything. Okay. Don't hesitate for anything. If you hesitate, then interviewer maybe lose the interest in you. Right. So, okay, sir. Definitely, I will take the lunch. Okay. So in this way, please reply. Okay. Now suppose that, and then he will ask you the paper. He will share you the pen and paper, and then he will made or interviewer made a two half adder, and then he or she will ask you to design the full adder. Okay. Now the question is, if you already know, please remember this. If you already know how to make it, okay, there are two types of candidates. Please try to remember there are two types of candidates who only know how to make it. Okay, they don't know the logic behind it. Okay, so if they have done it and they are not able to explain how they have achieved the circuit, okay, then they will definitely going to fail in this interview, right? So if you know the result, right, if you know how the circuit is basically implemented with the help of two half adder, please go in depth and identify that how the things are working, right? Please don't go and just make it. If you just go and make it, interviewer will definitely not going to take you because his interest is not in the solution. His interest is in how you are going to solve it. Are you able to reply some counter questions? Okay, so this is what he or she or interviewer is expecting, right? So now you have another one more input because interviewer asked to make a full header with the help of one sorry, with the help of two half header. So what I'll do here, I will take uh, another input, right? So this is my C in. This is my C in. Okay. Oh, I have done one mistake. Sorry, let me remove this. I have not mentioned the output. Let's see. Let me mention the output also here. A, B, C in, sum and C out. 0, 0, 1, 1, 0 and 1, 1, right? 0, so 1, 1, 0. Everyone know truth table of full adder. Okay. If you don't know, then it is very easy. We are just adding it. 1, 1 plus 1, 0, 1 and 1, 0, and triple 1, 1. So how this we are getting 1 plus 1, 0? Let me, this is 0. 1 plus 1 means 1 plus 1 means 2. You can say like this 2. Okay, binary of 2 is 0, 1. So this is sum and this is carry out. Okay, similarly 1 plus 1, 0, 1, and plus again 1. If you have 3, 1, 1 and 1. So this is your sum and this is your carry out. Okay. 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 So if you have any question, please ask. Okay, don't hesitate. And C out is 0, 0, 0. The carry out is 1. Carry out is 0. Carry out is 1. Carry out is 0. Sorry, carry out is 1. Right. 1 and 1, 0. Sorry, 1, 1. 0. And 0. Okay, so 1 and 1, 1 and 1. Please note this. Okay, now we need this final, we need the output. Okay, this sum and carry out at this final end. So we have one half adder and we have second half adder. Okay, so we have to make a such connection that we should get the output of full adder. Okay, so let's do one thing. Okay, so A and B and C in. Okay, let's start. Okay, so if you okay, one more thing I want to tell here. Basically, how to do it. Let me make one more time. Okay, then I can explain in much better way. 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. I am explaining you in my way. Okay, I'm going to explain you in my way how I want. Right. So we have A1, A and B. My A1 and B1. Okay. So let's start. Okay. So this A and B is getting basically these two input. A and B, I am basically getting input A, I am getting this, and input B, I am getting these options. Right? Now it is clear. So in the same way, why I have made this, why I have made, I'm going to make a separate truth table because I am going to perform one by one. Okay, I'm going to perform one by one. Okay, so I will give the input A and B here, and let's see what is my output. Okay, with this, with respect to the first XOR. Okay, with respect to the first XOR, we are giving the output 0 0 0 0 0 1 0 1 1 0 1 0 1 1 1 1. Okay, I am doing step by step. So the first step is put A and B here. Okay. The first step is put the value of A and B here. Okay. So I'm going to write the output of A and B in the next. The next in this truth table. So this is your XOR. Okay. The first XOR. Okay. So the output of sorry, the first XOR. The output of first XOR, that is A and B. 0 0, you know that in 0 0 you are getting 0 0 0 0 0 1 1 0 1 1 1 0 0 0 0 0 1 0 0 1 1 0 1 1 1 0. Okay, 0 0 0 0, and this again 1 0 1 1 0 1 1 1 0 1 1 0. See, the first part is completed. Okay, this is the first XOR output, right? I'm explaining you step by step. So you have received the one output, which is this one. Okay, now 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 this output, now I will also take the output of, now also I'm going to take the output of first AND gate also. Okay, this is not easy to explain, but I will definitely try to do it best for you. The first XOR and the first AND. Okay, the first AND means first XOR and the first AND. Okay, so the AND of this 0 0 is 0, 0 0 is 0, 0 1 is 0. Okay, 1 0 is 0. Okay, 1 0 is 0, 1 0 is 0, 1 1 is 1, and 1 1 is 1. Right? So the output, this is, I will name it first XOR. This I will name it first XOR, and this I will name it first AND. Okay, I hope this is clear to everyone. Right? Now we have another input Cin. Okay, and we know that we have another output, another gate is XOR. Right? So now I will go to the output of sum. Now please go through the output of sum. Okay, I will write it here in this page. Okay. Now you have another input which is called Cin. Please note, you have another input which is called Cin. Right? So what is the input of Cin? Okay, I will write it the input of Cin 0 1 0 1. Okay, 0 1 0 1 0. Right? 0 1 0 1 0 1 0 1. Okay, so this is the input which I have copied from the previous truth table. Now let's note down the output of sum here. The output of sum is 0 1 1 0. I am just copying the output of the sum. Okay, and 0 1 1 0. Let's see whether this is correct or not. 0 1 1 0 1 0 0 1. Right? So now you see your output. This is the output you are getting. Okay, now the question is where we have to add this line. Either we have to add this line to here or to here, or either we take this Cin and we add with some other gate. Okay, by watching the truth table, again by watching the truth table, I am just designing the logic. Okay, by watching the truth table. Right? So I have implemented the truth table of these two. Now my question is, I have a C in, but I have to adjust in such a way that I should get the output of sum. I should adjust in such a way that I should get the output of sum. Okay. So the sum logic is 0, 1, 1, 0, 0, 1, 1, 0. Right. So what I will do now, I will take the output of XOR. Right. I will take the output of XOR and output of Cin. Right. And sorry, output of first XOR and the Cin line. And if I am going to do the XORing, okay, if I'm going to do the ANDing, I will not get the exact output. But if I'm going to do the XORing, how this 0 and 0, 0, 0 and 0, sorry, I'm made my mistake. 0 and 1, 1, 1 and 0, 1, 1 and 1, 0, again, 1 and 0, 1 and 0, this one is, okay, 1, if I have not done any mistake, maybe 101, 101, okay, 110 and 110. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 0 is basically this is your XNOR. Okay, we will see what 1, 2, 3, 4, 5. Oh, sorry. 1, 1, 1, 2, 3, 4, 5. This is done. 1, 2, 3, 4, 5. This is done. 1, 2, 3, 4, 5. This is done. Actually, sorry, I have done mistake here. Okay, so 1, 0 per I will get. Okay, this is basically your XNOR. And 1, 1, 1 per, okay, 0, 0 per, okay, okay. So if I am going to connect this, oh sorry, this with this and this with this. Okay, if I'm going to connect my output of first XOR sum with the input of second XOR, okay, this is my second XOR. If I'm going to connect the input of my first XOR, okay, to the input of second, sorry, I'm going to connect the output of my first XOR to the input of my second XOR. And if I'm going to connect this Cin with the input of second XOR, then let's see what is my output. Okay, so here I'm getting A plus B square, sorry, A square plus B square. Okay, so whatever the output of A square plus B square, okay, whatever the output of A square plus B square is going to merge with the input Cin which is connected here. Okay, so this is what I'm doing here. So maybe let's see 0, 0. This is A square, sorry, A XOR B. Okay, this is A XOR Cin, right? Sorry, A, this is, and this is Cin. Okay, so 0 and 0, 0 and 1, 1. 0 and 0 I'm getting 0, 0 and 1 I'm getting 1, 1 and 0 I'm getting 1, 1 and 1 I'm getting 0. This is true. Now the input Cin is 1 and 0, 0, 0, 1 and 0. I have made some mistake here. 0 and 0, 0, 0 and 0, 0, 0 and 1, 1, 1, 0 and 0, 1, 1, 0 and 0, 1, 1, 0 and 0, 1, 1, 1, 0 and 1, 1, 0. Okay. I have made some mistake here. 1, 0 and 0. 1 here. 1 and 1, 0. 0 and 0, 1. 0. Let me check the truth truth table output 0 1. Oh, I got the mistake. Sorry, I got the mistake. This truth. This is actually wrong. This is wrong. This output of is 0 1 1 0 0 1 1 0 and then 1 0 0 1 1 0 0 1. Actually, I have copied wrong value here. That is why. Okay. So now 1 2 3 4. Now 1 and 0 is 1. Okay. 1 1 and 0 0 0 is 0 and 1 and 0 and 1 is 1. See. Okay, so I am getting my correct output of sum 0 1 1 0 1 0 0 1. Okay, see, output of sum is 0 1 1 0 and 1 0 0 1. Okay, that means if you have this, if you have connected this in with this input, second input of XOR, then you should have a valid reason. Sir, we are connecting, we are taking this C in, okay, we are taking this C in to the input of this, and the output is coming from this XOR is I am connecting to this line. Okay, so that is why I am getting the output of my sum 0 1 1 0 and 1 0 0 1. Okay, so my sum line is correct. Now I want the output of carry out. See, things are not easy, but it's very interesting. You have to develop patience while solving these things, and you should be very cool and calm while giving the interview, right? So now we are going to copy the output of Cout. We are going to copy the output of Cout. The Cout is 0 0 0 1 and 0 1 1 1 1. Okay, 0 0 0 1, because we have to prove the truth table. Okay, 0 0 0 1, because we have to prove the truth table. 0 0 0 1 and now 0 1 1 1 1. Now 0 1 1 1 1. 0 0 0 1 1 1 1. ओके, अब हमें ये प्रूफ करना है 0 1 1 1 दिस ट्रूथ टेबल. Again, go to the circuit. Okay, sum is proven. Okay, hence proof. Sum is proven. Right, now we have to prove the Cout. Okay, we need this 0 0 0. Now we have the AND gate from the first half adder and we have an AND gate from the second half adder. Okay, if we are going to connect it, please note, if we are going to connect it, then are you able to get the output? Let's see. Are you able to get the output? Okay, so for this we have to go here. The output of first AND. Okay, the output of first AND and the output of the second AND. Okay, please note here. This is the output of first AND, the output of second AND. Okay, so this sum is basically the output of the second XOR. Okay, second XOR. Now I will take here second AND gate. Okay, I will add the output of second AND gate. Okay, I will take the output of second AND gate. Please note the output of second AND gate. Whatever the input you are getting here and whatever the input you are getting here, okay, you are getting your sum output. Now you have another gate which is connected here. Okay, so whatever the input you are getting on this line, you have to take it here and you have to see what is your output. Okay, so let's see what is my output. So we have a first XOR and C in. Okay, we have a first XOR. This is my first XOR and we have a C in. Okay. First XOR is 0 and then say in. So 0, 0, 0, 1, 0, 1, 0, 0. Okay. So this is the output of my second. Okay, this is my output of second AND gate. Okay. Now, as I mentioned here, that if I'm going to connect this and this, these two, first AND C out and second AND C out, second AND C out. Okay, second XOR, second XOR sum. And if we are going to connect these two, okay, we cannot directly connect it, right? We need something. We need some gate to merge these two input into one. To merge these two input one. Okay, this is your first AND C out. This is your second C out, and then we have to go and merge and to get the output of C out. So which gate is required? Okay, so now the question is which gate is required. So I will take this. ओके सो अब यहाँ पे कौन सा गेट लगेगा कि हमारा आउटपुट सी आउट वाला आउटपुट आ जाए, ये वाला आउटपुट आ जाए, राइट? सी आउट वाला आउटपुट आ जाए, ये वाला, दिस वन. So we have a first AND and second AND. So if we put an AND gate, let's see, if we put an AND gate, whether I'm getting my C out or not. Put first AND and second AND, I'm getting the output 1. So this is rule out. Okay. So this AND gate is rule out. So you know that when you are giving input 0 and when you are giving input 1, the output is 1. Okay. Whenever any input is 1, output is 1. Whenever any input is 1, output is 1. Okay. Which gate? AND gate, OR gate. Again, the input of the output of first AND and the output of second AND. 0, 0, 0, 0, 0, 0, 0, 0, 0, but 0 and 1, we should get 0, but it is giving output 1. That means the AND gate is ruled out. So what gate I'm going to put it here? OR gate, right? So in OR gate, if both input are 0, output is 0. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 and 1, 1. Okay. So we are going to put here the OR gate. We are going to put here OR gate. This is my C out final. Okay, this is out my C out final and this is my sum final. Okay. Okay, engineers. Okay, team. This is how we can design the full adder with the help of two half adder. Believe me, why I am sharing you in detail, because whenever I am taking the interview, right? Whenever I am taking the interview, okay, I know that where my students are failed. Okay, they know the circuit. Maybe they have seen somewhere, they have done some rectification, and they have just prepare it or store in their mind. Okay, this is how the two half adder is used to make a one bit full adder. But if I'm asking why we have chosen this OR gate here, or why I am connecting this line with this line, okay, why I am connecting this line with this line, why I am not connecting this with this, or why I am not connecting this with this, okay, we can do, right? Why? So they basically they fail to reply. They start thinking, and this is the reason where interviewer lose the interest. If interviewer lose the interest, then you are not going to clear the first round. If you are very performed in some previous question, but If you failed in this, interviewer will lose the interest and he say or she say goodbye to you. Okay, so this is the one very simple thought process I have explained. Okay, now the second and very lengthy question is that I know this will take another 1 hour. So I'm going to decide it whether I should take it right now or not, because I thought I should explain both the things in one shot. Okay, so what is my second question here, which I ask you to prepare in my third class or fourth class. I ask you to make a full adder with help of NAND gates. Okay, I ask you to make a full adder with help of NAND gates. Okay, so the sum expression is A XOR B XOR C in. This is a sum expression. This is a C out AB plus BC in plus C in A. Okay, so okay, I'm designing the basically this expression into the gate level. AB. I'm using the different color because I want to show you A, B, C. This is my OR, first OR. This is my second OR. Okay. Now the question is, the question is how many NAND gates? Okay. How many NAND gates? How many NAND gates required? How many NAND gates required to make one bit full adder? Okay, so we are going to convert into full adder. So there are two types of replies. Sir, you are asking the maximum or you are asking the minimum. Okay, so we will fill it here. So let's break this into the NAND gate. So I will choose the same color. Okay, I'm going to choose the same color. So this is so I'm going to convert the XOR into the NAND gates with the same color coding. Okay, so this is for first one and it's yellow. This I have given you the assignment. Maybe I don't know how many of you have solved it. Okay. Now let's do one by one. One, two, three. This is a conversion of AND gate in NAND gate. Okay. Okay. This is OR gate. This is OR gate. This is the first OR gate and now the second OR gate. Okay. So this is your full adder. This is a full adder expression, and this is the implementation of full adder in a gate. Okay, this is your in terms of gate like XOR, AND gate, and OR gate, and this is the conversion of the circuit into the NAND gates. Okay, so total maximum NAND gate is required 20. So let's see 1, 2, 3, 4, 5, 6, 7, 8. Okay, then 9, 10, 11, 12, 13, 14, okay, 15, 16, 17, yeah, 18. I made some mistake. Wait. I made one mistake. Yes, sorry. Sorry. This is now correct. Okay, 17, 18, 19, and 20. Okay. So, my dear engineers, now we have a 20 maximum gate, and we want in 9. Okay. So the question is, whenever such type of question will come, okay, implement a NAND gate, implement a adder, half adder, full adder, half subtractor, full subtractor. No one will ask 4-bit adder, 2-bit adder, 3-bit adder. Okay. Everyone will ask the question like, how many NAND gates required to make a XOR with shorting, without shorting? Just you go through our first, second class, right? So, so how many NAND gates required to make a 1-bit half adder, 1-bit full adder, 1-bit half subtractor, 1-bit full subtractor, then mux, demux, encoder, decoder, okay, 2-bit multiplier or 2-bit divider or 2s complement. Okay, 1 bit, 2 bit, whatever, or comparator. Okay, so in this way you have to ask, sir, how many you are asking, the you want to know the reply, the maximum or minimum. Okay, so definitely the interviewer will say ki, okay, tell me both. So in that case, use in that case design the all the circuit with the help of those NAND gates, or with the help of shorting of NAND gates. Okay, because with the help of shorting of NAND gates, we can basically reach up to the minimum number of NAND gates. Okay, if you remember in our first class, second class, I have asked you to design the any gate with help of NAND gates without shorting. Okay, without shorting. Now here you have to use the NAND gate with shorting, because with shorting we are getting the minimum number of NAND gates. Okay, so see, this is your minimum number of NAND gates of XOR. This is the minimum number of XOR. This is your AND gate. This is your AND gate. This is your AND gate. This is your OR gate. This is your OR gate. Okay, now you have to reduce it to 9. Okay, you have to reduce it to the 9. This is your A, this is your B, and this is your C. Okay, so this will take time, another 1 hour. So I'm not going to tell it here right now, but in my next class, and I will upload, or I will take one more class to explain this, how to reduce it to make it 9. Please don't leave it. Okay, I will upload it, and and another demo is pending, or another demo is pending, which I will upload it soon, that how to make the multiple bus. Okay, so my the complete half adder to 8-bit adder is complete circuit is over in my channel, right? So I'm covering both things. I'm covering the theoretical part, interview part. I'm also covering the your practical also. Okay, I'm not taking care of the K-map, pause, SOP, etc. You know it is good, but you have to solve it without K-map. Because in any case, if you forget the K-map, if you forget the Boolean expression, if you, because that is very confusing. If you forget any De Morgan, Morgan, anything you forget, then you will lose your confidence. So that is why I every time I promoting my candidates to solve the question with the help of hit and trial, because in interview people will never ask very lengthy questions. People will ask the question very easy question, and that you have to solve it with the help of hit and trial. Okay, okay, team. So this is what I will explain in my next class, because this will take another 1 hour. Okay, this is not an easy one. If you know, really very good. If you have solved, really very good. But if you have not solved it, I am going to solve it, because this will take another 1 hour, right? And this I have explained for you in very structured way. If you facing any issue in any problem, please send me the message in a group, or just go through this class. It is available. Again, before ending, I have changed my strategy regarding your certification. Okay, certification. I'm not going to give you the any certificate from now, just on behalf of test, because many of you are serious, but maximum are just appearing the test for the certificate. So this is not I'm going to promote it, but yes, I will give you the certification if you complete the project. Okay, project, any project, sign calculator or algebraic or Boolean. Okay, for this it required a adder, subtractor, multiplier, okay, mux, demux, decoder, and 2s complement. Okay, I'm going to teach you each and everything. Use this component, design this component on your Xilinx ISC tool. Okay, मैंने आपको ऑलरेडी दे दिया है, हमने आपको प्रोवाइड कर चुके हैं फॉर विंडोज 10 एंड विंडोज 11. Okay, if you have not uploaded or downloaded, please do. ये आपका एक समर ट्रेनिंग की तरह काम करेगा ये प्रोजेक्ट. इफ यू आर वेरी फार फ्रॉम मी, if you're not able to come, if you're not able to join the online class, if you're not interested to pay me extra, okay, in my separate class, very simple. Everyone is working for money. Okay, we have to accept this. If you go in job, you will ask for salary. You will never say, sir, I'm going to work for free. No, for 1 day, 2 day, 1 month, 2 month, 3 month, 5 months, 6 months, you will pay, you will work at no cost. But seventh month, you will definitely looking for some stipend salary. Okay, so everyone is here in this entire world is working for the money to survive. Okay, so that is why I am taking this class just to explore that my juniors should have a basic understanding without investing any single cost. Okay, but yes, if you are coming to my the premium classes, to my paid classes, there you have to pay. Nothing is free. Okay, just remember this. Okay, but yes, I'm making the things easy for your summer training. If you are not able to take any session, if you want some certificate to submit in your college, I can provide you, but you have to complete the project. You have to show me the working of anything, right? Plus the theory. Okay, theory of both combination and sequential. Okay, so with this only combination and with sequential, we have another set of projects. Okay, another set of projects. So this is all from my side. I'm trying to give you the best thing. If you are really want to work, please download the tool, install the tool, go through the demo one by one, make it, revise, go rewind it and make it, rewind it and make it. If you face any problem, drop a message on my WhatsApp or in a group, we will solve it. Okay, so this is all from my side, and please be focused, be disciplined. Whatever you want to do it, you can do it. But for that, you have to be very, very, very strict with your schedule. Okay, don't disturb your schedule. If any case your schedule is disturbed, please try to make up next day. Please make your schedule, work on it. Give at least 1 hour, 2 hour for one topic. Okay, choose the topic every day. Don't do it like this. Give one topic for 1 week or 2 weeks. No, this is not the best preparation. In that case, the backlog will be create a pressure on you. Okay, so this is what I am helping my juniors to use this strategy to learn the things. Okay, so thank you everyone. This is all from my side. Good evening and Jai Hind. Bye everyone.